So let's start the static analysis. And when we start the static analysis of a simple beam, you will understand maybe in detail. Now what we are going to do is we will model a simple beam, a simply supported UDL. I will just go to STAAD. Okay, this is our window. At the right side, you can see there are these two windows. At the top, we have nodes. At the bottom, we have beams. So we can always start modeling by inserting one node. So at the node section, you have X, Y, Z. You can see the axis of our main model. We have the Y axis in the upward direction. Then we have X and Z axis in the plane. So these axes at the bottom, you should understand Y is upward and X and Z is in the plane. So I want to start modeling. So I will start with 0.0. So in the node number 1, I will just mention 0. 0, 0, 0. So when I just click on enter, I get my node over here. So this is the node. Now I want to have node number 2. I want to have a node, second node at a distance of 5 meter. I want to create a beam of 5 meter. So in X direction, my second node will be X will be 5 and Y and Z will be 0 because I want at the same level. Now you can see the other node is created. And this you can see this is at the bottom, this is at the top. The reason is this window is into 3-dimensional. We are seeing a 3D view of these two nodes. You can see the X line is also along this line. So this is the line where we have 0 and 5. Now I want to connect these two nodes to model my beam. So in geometry, you have some buttons. I will just briefly explain you. This you have clipboard from where you can copy, paste, you can delete, you can cut. Here you have option for grids. Later I will be explaining you how grids are useful. Structural wizard, again we will discuss this later. Translation, repeat, circular, repeat, generate, rotate. So these are some of the commands in what you can apply on your structure. Next is nodes. Now we have created these nodes. If you want to move the nodes, you have the option away from here. You can move it. You can renumber the nodes if you want to change the number of nodes. Like you can say right now we have two nodes. First one is number 1. Second one is number 2. When I click on any of the node, that is coming in red color. If I click the other node, that you can see the other is in red color. Next option you have of beams. When I again click on the window, sometimes what happens if I click outside, if I click here outside, sometimes my beam command is not visible. Like you can see I clicked outside. Now this is not active command. If you want to activate all these commands, just click on your main white window. When I click it once, now all my commands are again active. I can draw beam from here. I will just click on add beam, connect my first node. I will just press it once and I go to my second node and again click on it. So I have created this beam. You can see all other commands on beam what we have, you can apply from here. If you want to model a plate, you can draw a plate from here. That's a 4-noded element. If you want to model a solid, I will be explaining you later what is the difference between plate and what is solid. If you want to have a 3D, then you go for solids and you have other things. So these all things what we use in creating a geometry of a model, those are available over here. So using the command of node and add beam, I drew this beam. Okay, now I can just press the escape button. Then I have my normal mouse. Okay, so for my case, I have created the geometry. I have node 1, node 2. Now you can see in the bottom, you have beam. When we drew this beam, directly it showed beam number 1. You can see when I click on beam number 1, the whole beam is in red color. That means it's chosen. Node A and node B. Point 1 is connected to point 2. That is the reason it is beam 1. So this is the way in which we can, the numbering of nodes and the numbering of beam is done. After the geometry, next is properties. I want to assign properties. I just click on property. Here I have the table of property. So what is important for us now? Section database. I will be explaining you the other commands as and when you go on using them. But for now, I will just show you section, click on section database. Sometimes it takes time to open. What is section database? I will just show you when it opens. Here you can see this is the window which pops up when we click on section database. This is a database of all the sections which are available in the world. We have the American sections, we have the Australian sections, Brazilian, British, Canadian, Chinese, Dutch, and all. But what we are interested in is the Indian section. So just find Indian from here, click on Indian. In Indian, again, there are many kinds. We are interested in S shape, that is fine. In this window, you can select the beam. I will choose ISMB 600. So I will go down at last, third last, I have this option ISMB 600. I just clicked over it. Material is already ticked. It is steel. Okay, these I will be explaining you later. I will just say add. Okay, after saying add, after clicking on add, I'll close this window. Now you can see here I have one reference, one section is ISMB 600, material is steel. Now it's just in the table. I have not assigned it. What I will do, I will click on my beam. Now it's in red color and I have already chosen ISMB 600. At the bottom, assignment method. There are 4 options. I will today explain you just the first one, assign to selected beam. So whatever beam we have chosen, it will be assigned to that. At the bottom, we have the option of assign. I'll click on assign. I'll say yes. So now my beam is assigned with ISMB 600. Geometry is done, property is done. Next is material. Material, it's already steel. It's written over here. I do not, if you have any other material, you can choose from here like concrete, aluminium. Yeah, you have other options over here. Specifications, we are right now not giving any special specifications, so just leave it. Support, click on support. Right now, by default, it is always no support. Here you can click on create. If I click on create, I get this window. I just bought it at the center. In this window, you have many options, but we want pin connection. So I'll just choose pinned and I'll click on add. Now I can click on this support. Support to its pin connection. I have clicked on it. Here I have option use cursor to assign. I am choosing the third option what is available. Assign to selected node is also there, but no node is chosen now. Use cursor to assign. So this is a simple method to assign it. Now you click on assign. When you click on assign, you will get it's written here assigning. And when you bring this on the white paper, you see the symbol of a pin connection. So just bring it near the node and click. Bring it near the node and click. Okay. Again, press escape. Now both of my nodes are with pin connection. Support is also done. Now I want to go to loading. I click on loading. In loading, you can see this. At the top, we have definition. Right now, we are not interested in that. At the second option is load case detail. Click on load case detail. Here you have bottom option as add. Click on add. When you click on add, it asks you enter the load case. So I will just label it as load case 1, whatever is the default. And I will click on add. And I will close this. Now you see we have the load case 1. Again, I have to choose load case 1. Again, I have to click on add. Now when I click load case 1 and when I click add, I get this other window in which I will be able to apply my load. Whether I want to apply self weight, then I can choose this. Whether I want to apply nodal load, then I can choose the second option. But in my case, I want to apply member load. And in member load, again, there are many types of loads, but I am interested in the first one, uniform load, uniform force, UDL. And the value -10. The reason why I'm giving minus sign because I want to apply it in the direction of gravity downward and my y-axis is upward. That's why I'm giving -10 GY. I will click on add. GY is the global y direction. In the directions, you have this XYZ. First option is the local XYZ. Second is the global XYZ. And third, for any other axis, we have PXY, PZ. When we want to use this, I would tell you later. Right now, what we are interested is the global axis, that is GY. and D1, D2, D3. These values, it will depend if in our member we want to apply only a patch load or a particular load. So when we use this, I will be explaining you again later. Right now, W1 generally throughout the member, UDL is 10. So I will type 10 kilonewton per meter, and I have already clicked on add. So I'll close now. Now you can see here it's written uniform load GY minus 10. It is showing question mark because I have here, but I have not applied it on my model. Again, I will choose my beam. I will click on this load. I will assignment method. I have assigned to selected beam. I will click on assign. Do you want to assign? I'll say yes. Now my load is applied on the beam. Okay, loading is done. UDL is done. Analysis. I will go in analysis. If I go in analysis, I get this window over here. I will go in define command. Here I get the option of perform analysis and many other types of analysis. I want to perform a general analysis. I will say no print. I will click on add. I'll close this. That's it. Designing part we are not going to do now. That is the reason I am leaving that as blank. Now what I will just overview tell you geometry. When you click on geometry, you create node, beam, geometry is done. You go in property, you choose section database, you choose your member. That is fine. You go in material, material is already chosen. You don't do anything. Specification, you do not have any specification, leave it blank. Go in support, create a support, give pin connection, go in loading, create load case 1, click on add plus button, then it opens. You have applied this load, go in analysis, give the command of perform analysis. Done. These are all the steps what we did in analytical modeling for a simply supported beam. Now at the top you have the option analysis and design. Click on analysis and design. Here you have the option of run analysis. Click on run analysis. It shows do you want to save it? Just say yes. Now you can see after a certain time analysis is done. 0 error, 1 warning, 1 note. Okay. Here again you have 3 options. View output file, go to post processing mode, stay in modeling mode. So for now, I will just leave whatever is coming, stay in modeling mode. I'll click on done. Okay, so this is done now. But now I want to see the result. To see the result here in the workflow, I will go in post processing. If I click post processing, I get this result setup option. Right now, I only have one load case, which is already in the selected area. I will just click on OK. So I get this result. Let me here at the top in the result, you see displacement. It is already ticked and you can see some green line. I want to zoom in and I want to see what properly. So I will press the control button and I will scroll the wheel of my mouse. When I scroll the wheel of my mouse, you can see this is moving down. This is the deflection of my beam, right? Green part is a deflected beam. I will just click on it again. I don't want to see deflection. MZ, I want to see the moment. If I click on MZ, you can see moment. Again, I press the control button and I scroll the wheel of my mouse. I can see the moment, the direction of the figure of moment. This is correct. If I want to compare it with my UDL, for UDL, I will get this kind of moment, bending moment diagram. Also, I'm getting similar kind of bending moment diagram. Okay, again, I'll click on MZ. Now I want to see shear force. Shear force will be Fy. I click on Fy, I get shear force. Again, I'll press the control button and I'll see. You can see at the support, it is going up, then straight down, it is going up. If I see the actual, it is also the same. So here you see Fx. Fx means the axial force. Axial force, we do not have any axial force on the beam. Again, I'll click on Fx. Second is Fy, shear force. I already showed you the shear force. Again, I'll click on Fy. Fz is the torsion. We are doing in 2D, so we do not have Fz, Mx, My, and Mz. Mz will be the moment. Mx, My again with this will be moment in the other things. Mz, you can see the moment. Okay, so what we showed today, what I showed you today is just the diagram, and we validated the diagram. This is the modeling what we did, the free body diagram. Also shear force diagram, we only saw the diagram. It is also the same shape. Bending moment diagram, we saw it is the same shape. In the coming lectures, we will also see the reaction values. We will also see the shear force values, bending moment values, deflection values, and we will validate. Also today you understood briefly how you can model simply supported beam. Okay, so for the people who do not know anything in STAAD Pro, this was just the beginning. If again you want to go in modeling, you can click on analytical modeling. And again, you are in the model. If you want to do any changes, you can do from here. Okay, so this is it for today. This was just a small overview of STAAD Pro software. As days pass by, we will be understanding other parts. We will be understanding other ways in which we can model. We will be deep diving into each and every command.